Good morning friends. Today we are going to discuss about the spanning tree under the greedy algorithm. Okay. Under this we are going to discuss about the two important algorithm. First one will be the Prim's algorithm and one more will be the Kruskal algorithm. Before discussing these algorithms, first we need to get understand what is meant by the spanning tree here. Okay. Spanning tree is nothing but a tree here. All the nodes should be get connected and there is no cycle form here. Means that this is the one graph here. Okay, it is consisting of the four vertices, say A, B, C and the D here. All the nodes should be get connected. A to B's connection is there, B to C, D is there, B to C is get connected, but there should not be any cycle here. Okay, if you add A to C here, that forms a cycle here. Due to that reason it not becomes the spanning tree here. Okay, similarly if you create one more edge between C and the D, again it will create the one cycle here. Due to that reason this is also not a spanning tree here. Okay, the spanning tree is a tree here. All the nodes should be get connected and there should not be any cycle here. Okay, say this one, this is A, this is B and the C. A is connected to C, B is connected to A here, C is connected to A, but there is no any cycle. This kind of the trees are going to be called as a spanning tree here. Okay, first we are going to discuss about the Prim's algorithm. Okay, how the Prim's algorithm works here. Okay, before explaining the algorithm here, first I will explain the problem how it works, then we look for the algorithm here. Okay, this is one graph here. Each vertex is get connected here. Each edge is going to consisting the respective weights also. Means A to B is having the one edge is having 4 here, A to H is having 8 here. Similarly G to H is having the 4 also. Okay, then how to solve this algorithm here, how to solve this problem using the Prim's algorithm. Okay, now we need to make the three important things here. One will be the arrange all the vertices here. Okay, like A, B, C, G, H and I, all these vertices are belongs to graph G here. Means G belongs to all set of vertices here. Okay, now parents of each vertex. Okay, parents of each vertex is initially set to null here. I will write here the n now. Okay, and the vertex weight is set to infinity. Each vertex set initially set to the infinity here. Now set all the vertex set initially to the infinity. Now how to start or how to traverse this algorithm? Take any one node as a root and it set this value to 0 here. In this algorithm I will take the A as a root vertex here and I will set value to 0. We will set this value to 0 here. Okay, now initially all vertex value is set to infinity here. Once I set vertex A as a root here, the root value becomes 0. This is the queue here friends. In the queue now I need to add all the vertices in a graph here. Okay, all the vertices along with their weights, initially its weights are infinity here. Once I selected A as a root here, root value becomes 0 now. Due to that reason I will update the queue here. Once you added A as a root here, what the algorithm is telling, minimum among all the weights from the queue, extract that vertex from the queue here. It means that A is having 0, other vertex is having the values minimum infinity here. Among these values, which one is the minimum value? No, extract that vertex from the queue here. Means that here the A is having the minimum value. I will extract the vertex A here. Once you extract the vertex from the queue here, I need to find out neighbors for that vertex. A is having the neighbors B and the H here 100%. Okay, A to B value how much is there? 4 is there. A to H value is how much is there? 8 is there. A to B here, B is initial vertex value is infinity here. 4 is less than infinity, yes or no? Definitely 4 is less than infinity, so we'll add that value here. Then the B parents become A. Similarly A to H is how much value is there? 8 is there. H is having the value infinity here. Okay, 8 is less than infinity, yes or no? Due to that reason I will select 8 as the minimum here. 8 added here and its cost parents becomes A here. Now update the values. What is that? B becomes the 4 now. H becomes 8 now. Yes sir. H becomes 8 now. Now among this algorithm, among these vertices, which one is the minimum now? 4 is the minimum. Now extract the vertex B here. Okay, once you extract B here, B neighbors are C as well as the H here. B to C, how much is there? 8. Its parents becomes B here. B to H, how much is there? B to H is having 11 now. Already H is having the weight. H is having the weight here 8. Yes or no? This will be the 8 now. Already 8 is there. L1 is not less than 8. Due to that reason, I will not add this one. Okay, only will update this one. Its parents become B to C here. Parents become B here. Okay, and B to H already is having 8 here. Due to that reason, I will not add that one. Okay, only I will update the vertex value C equal to 8 and H will be remain same here. Okay, now again we'll extract the minimum among C and the H here. Which one is the minimum? C. You can select anyone, but I will select here C here. It comes to here C now. C value is 8 here already. Okay, C is having the neighbors I as well as the G here. Okay, C to I is having the value 2 here. Initially I